My name is James. I run a data science consulting firm inside of the Bay, and I also run a few different stealth startup kinds of companies. I'm currently an adjunct lecturer over in the Department of Statistics at Stanford, teaching Stats 290, which is computing for data science. And then before I moved into the Bay Area, I basically spent my academic career at Illinois. And inside of the Quarto ecosystem, I have a tendency to build a lot of Quarto extensions. So I started working a little bit on WebAssembly extensions like WebAR and pyOpenSci before Quarto Live came along. So I'm pretty familiar across the board with all of the technologies, and I'm really excited to share some of the ideas that I've noticed really work well in classroom settings. And then the last part here that I should mention is I also have an affiliation with the Data and Technology Innovation Group over at Illinois. So I have always tried to have some of the latest and greatest ideas being presented with data alongside of technology. So that said, when I moved to the Bay, there's this wonderful museum that is called the Exploratorium. It was created by Frank Oppenheimer, and if you watch the blockbuster movie of Oppenheimer, Frank is the lead character's brother, and he designed this museum as a way to encourage people to experience science in new ways. There's a documentary, very short, 15-minute long documentary called Exploratorium by John Borston back in 1974. So one of my favorite things that Frank said was it shouldn't be a static thing. It should be one where people learn what's happening. And the only way to learn what's happening is to change what's happening. So he boiled this down into 4 different tenets. First, he was encouraging visitors to his museum to have direct manipulations of concepts. He wanted them to immediately have some kind of visual feedback. He was trying to encourage students and visitors to have ownership of discovering these new scientific ideas. And then lastly, he hoped throughout presenting science in this new way, there was a lifelong desire to really retain the knowledge that was gained. If you are ever in the Bay Area, I highly recommend going to the Exploratorium. It's at Pier 15. Part of the Exploratorium really is this entire idea that everything that you do in this museum is really through active learning, which forces a level of ownership, your own learning, through more of a learner-driven exploration. So we usually see active learning being one of the huge tenets that's being emphasized in higher education because students will want to engage more with the material. They'll have a longer-term retention, and their underlying knowledge models really are better. So when we think about the Exploratorium idea and we think about active learning in the 21st century, the question comes up about how can we bring this into the data science paradigm? And to do that, we need something that's known as an explorable explanation. An explorable explanation was an idea that Brett Victor, formerly of Apple, who designed the iPod, presented in a series of interactive essays dating back to 2011. And his entire idea with these essays are this entire notion that text should not be information that should be consumed, but text should really be this environment to think in. So through explorable explanations, he came up with this idea of a reactive document. You saw a little bit about this when George was initially playing around earlier. And he also had interactive examples. So everything had a science museum-like feel where you can immediately play and see what's going on. But perhaps the most important part here is it really pushed for this idea that people that were reading what someone wrote could actually verify their claims in real time. So I've had a few attempts across the years bringing something very similar into the data science realm. Back in 2018, I started to explore embedding our code directly inside of HTML slides. So back in those days, it was a little bit more archaic and problematic to bring R in because we needed to actually have some kind of computational backend or a server where we could send the students' code to be run on. Well, the young version of me didn't truly appreciate how many different kinds of resources were required to sustain something like 1,000 requests within the span of, let's say, 5 minutes. So when we started to scale and have more students, because there was more interest in data science, we started to run into more issues with running it out. So I'm really, really excited that Quarto Live has come into play. I'm really excited that it has changed the entire paradigm when it comes to creating these explorable environments, because it makes the way that you can express yourself, and it makes a way that you can actually design curriculum for the 21st century in a way that preserves how your initial static code that you've been generating before has existed, but now you can add in this entire new interactive welcoming component. And it's really able to do this because of two key pieces that George has mentioned. One was pyOpenSci, which is basically allowing you to run Python in your browser without a server. And then the second is Observable. And really that integration that Quarto Live has with Observable is key to some of these environments. And I'm going to talk a little bit more about that in the next few slides. One of the parts that I also do want to emphasize that George did show is he even has a nice little bonus piece of technology to really inspire this. So we can put inside of any slide deck that we have, all we have to do is press tilde, and what ends up happening is we now have an entire environment where we can start saying 1 + 1 and then running it, and lo and behold, you have 2. If you saw his previous example with respect to plotting, you'd see a graph that appears there as well. So it's basically taking how we can present information, and it's making it in a way that truly inspires a level of engagement and interaction that previously it wasn't really possible or feasible in many of the environments. So here's one of the best examples and most straightforward use cases really for Quarto Live. I can take a code cell like what you're seeing here. I can add in an option to have students explore how to make different list comprehensions. So here I can provide guidance in terms of where they need to modify a component through a fill in the blank exercise. And if they don't correctly do it, one of the really nice parts about Quarto Live is it automatically will pick up this entire notion that there's a part that's missing. So if I change that to say 5, I can have them use this checker system to gain feedback in terms of maybe you want to explore a greater sequence, just so that they can understand how this list comprehension is working. So instead of 5, you can go up to 10, and then you can provide positive feedback or praise to sort of further push them along in terms of the effort. And one of the other parts that's really nice is we also have built-in ways of putting in countdown clocks. One of the key aspects of an environment like this is you can very quickly lose track of time because you can just be exploring and you can be trying out new things quite frequently. So by having a countdown clock like this, where I can start it and I can stop it, there's a clear designation in terms of what's going on. And if we jump over to the second tab, so throughout the remaining examples that I'll show, you can see everything that is really required here is basically all markdown. And the first line that we have here, it's basically setting up Quarto cell attribute, where it's describing what the exercise is. We can go and see that the next line is just a regular list comprehension. And then we can see over here that that's just returning the object. So really nice little ways of having this inline annotation. Now, one of the really cool parts about the integration that Quarto Live has is the fact that we can, again, take any kind of equation that we might have, and we can make it immediately available for exploration. So here, what you're seeing is the usual equation of a line. If I start to modify this, so here I've said b equals negative 4.2 and a is 5 in terms of the slope, we can see that we have the line going across y equals negative 4.2. And if I start to drag downwards, we can immediately see a change in the entire slope. So you can take any kind of concept that you might have and you can very quickly make modifications. So all of this is really due to, again, Quarto Live having an excellent use of Quarto's built-in observable support, to the point where we can take any kind of existing observable libraries or JavaScript libraries and bring them in and integrate them with existing R or Python code. So in this case, there's one really nice library called Tangle that was ported over into Observable by Mike Bostock. And in the previous example, you can see directly through that slider drag, we were able to very quickly change the equation of a line. So moving a little bit more forward, we also have the ability to have an exploration of bins. So here what you're seeing is a histogram, and the histogram here, we're making a specific assumption about the number of bins that need to be set up on an imaginary number line for numbers to be classified into. So if we go, let's say 10, our histogram looks pretty much like a regular normal distribution. But if we start going all the way up to 1,000, it becomes very, very sparse. So this is one way that we can encourage students to learn about how an underlying fundamental graph is really being constructed. And if we go a little bit more forward, we can even do some really interesting things in terms of contingency tables. So here, right, we can start to manipulate a cell level component, and we can see what happens when we increase the number of cases where somebody has an exposure rate to, or we can show here what happens if somebody isn't exposed. Now, one part here is Quarto Live has really nice built-in error handling. So you can set it up so that even a use case where you have cases being 0, it won't cause anything problematic to happen during your presentation. You will get an error message, as you can see, division by 0, but across the board, it's really, really nice as a result. And because I know George is a physicist, you can very quickly scaffold different kinds of physics examples directly in here as well. It doesn't have to be data science oriented ideas. Anything is really possible, which is really, really cool. Similarly, we can have a little bit of an exploration in terms of k-means clustering. So we can set clusters with like 6, or we can have 7. The sky's the limit, really. And we can also start to take different kinds of penguins, and we can look at different subgroups of the penguins and have a conversation on how these clusters came to be without having to have the student make multiple graphs by themselves. All of this logic in terms of this graph unit is just controlled by a simple drop-down menu. And we can immediately have everything look like an entire full graph with everything being highlighted. We don't have to have any kind of shadowing or anything along those lines. So it makes data explorable in new ways. I would also say here, we can take real life data like you saw with penguins, and we can apply that same original clustering example here. So here I can say I want 4 clusters, and we can slowly start to see what do those 4 clusters look like in terms of what we have on our graph. So there's a lot that you can really do. And if we wanted to go back a little bit more into that programming aspect, we can also have guided exploration of different operations. So here, right, we can have students select different kinds of mathematical operations. So when George was pulling up the IDE and he was squaring a number, it went unfortunately to infinity. Here we're seeing an operation of just doubling a series of numbers inside of a range. And you can dynamically increase the number of observations. and you can see how the code is immediately updating and changing. So this provides a way for having students access material in a way that they couldn't easily get at before, especially if they're just starting out in terms of programming knowledge. Now, another part that I really like about this, and I wanted to go back to that initial example that I had when I was talking about my first attempts at bringing code into lectures. One thing that Quarto Live does have is it does have the ability to run all of these lines of code. So here we can say we want to classify the weather, in this case temperature. So here I can go ahead and I can try out different kinds of data points and see what the actual threshold is in terms of what goes on. Now, you'll notice that when I set it to 50, what ended up happening is we finally have an error that comes up. So the error message is really clearly stated, name weather is not defined. And if you look right inside of this if case on line 8, we have weather is greater than 50, whereas weather should be switched out to temperature should be greater than 50. And then lo and behold, once we make that slight change, everything works. So we can further incorporate in data sets, and we can have students just work on data that I would say are medium-sized most data sets, because as you start to get to bigger and bigger data sets, the student has to be downloading that information, and how these documents and explorations are being served to them is always over the internet. So there's a limitation here of how much data you want to send to a student laptop, one. And then the second part here is if you have a massive data set, remember that, again, students are actually running this data locally. And not all student laptops are created equally. Many of the students, as George has pointed out before, are mobile first students. So they're using their phones, they're using their tablets, instead of having a really nice laptop to work off of. So in a case like this, we can have students work on real data like Palmer's penguins. We can have them practice with pandas or polars in terms of subsetting. And we can, again, provide them instant feedback without having it tax any of our original servers. So here, if I very quickly take the solution down below and I plug it in and I go ahead and I run this code, again, notice we have in this entire output basically the filtered data frame alongside of some level of praise saying we got it right, which is, again, really nice to be able to do. So when you're thinking about making the leap over into more of these explorable explanations and taking Quarto Live to the next level, there's a set of design patterns or good approaches to really stress what the underlying concepts are and to promote learning in the best way. The first part here is always try and do progressive disclosure. So when you initially saw all of the code, it was starting off in a simple way. And then as we progressed through, we added different layers of complexity. It's much, much better in a case of these explorations that the student isn't overloaded by choice, and you're able to tie, if you make a change to this variable, well, that'll cause a ripple effect in this manner. So that takes us into that second point. If you can have as much direct manipulation as possible, Quarto Live can provide a very feature-rich feedback experience through a lot of great real-time updates. And you don't only want to be working just with code in this case. You saw examples where we're just having them explore a visualization by dragging a bar or by selecting the group that we were interested in. And if we go a little bit more forward, outside of that set of design patterns, the absolute best practice here would be anything that you show, you really want to emphasize a clear relationship. No matter what, as a student will work through what's happening here, they'll learn something. It might not exactly be what you want them to learn, but they'll pick up on the underlying relationships. It's really amazing how patterns get detected. The other thing that I should also emphasize here is you do want to have some meaningful bounds on these explorations. Don't feel as if everything should be accessible. Some of the best sandboxes or ways that we can allow for construction in a constructivist framework do have some limits. And then for that third point here is some students might not appreciate a lot of the interactivity. Some will focus more on, I want to know exactly what I have to do for my homework kind of approach. So do try and have a fair balance between having a student discover all of the relationships on their own versus providing a piece of feedback. So I know I've been talking for a while, and I appreciate all of your attention on that. I do have two final parting gifts for you. The first parting gift that I have is course website and course webpage. I'll link this into the description below. But basically, this shows how we can use Quarto Live to provide a lecture in real time, linear regression. And we can have two different tabs, so you can immediately jump back and forth between R and Python code. And for some reason, that was a little bit off, but I'll check on that, and it should work. It was working, I should say. But the main part here is you have this unlimited flexibility to make all of the material that you're seeing right now available for students and provided in perhaps the best discoverable way. And the last one that I want to very quickly do is just this demo lab. Quarto Live, outside of just being great to use inside of slide decks for quick concepts, you can really start to drill down and have students explore different kinds of problems just on a regular lab or just on a regular HTML page that is containing like a lab assignment. So again, sky's the limit with what you want to make accessible for students, but there's so many really powerful ideas. And again, one of the greatest parts about the underlying system that Quarto Live is built on, that is Quarto itself, everything that you're seeing is being served to you through GitHub. So there's a level of version control. You know exactly when something is being deployed. You can share both a rendered document and you can share the underlying source, and you can have anybody collaborate. And again, inside of this repository, everything here is just immediately built and rendered on commit and push into the repository itself. So I've tried to document as much as I possibly can. I highly suggest if you have a time, definitely take a look at those materials and try to incorporate them. So a few final parting pieces of advice: definitely get both Quarto Live and Quarto Drop. These are extensions. When you're working with an extension for the first time, it's very important to note that extensions only exist in your current Quarto project. There isn't a global library for extensions. This is done for reproducible reasons. So each extension has to be reinstalled for each project that you're doing, but the installation is very straightforward, very quick. As you can see, 2 commands, and we have 2 extensions for that project. When you're building out a document, it's really useful to specify what kinds of packages your document is going to depend on through the pyoid key right underneath the format that you're using. So in my case, I'm using this live-reveal.js format. So by adding packages here, what happens is they will download at the start. So when the student opens up the document, and it will prevent later code cells from being run. And it has a better visual indicator to say, this document is ready to be explored. And if you're interested here in sort of Tangle, which is where we're getting some of the dragging options, it's a very quick, no more than, in this case, about 7 lines of code to very quickly create an input like that. And then to bring this input variable into Python only requires a YAML sort of definition of what the variable name is that was initially designed for Tangle itself. So view of var is right there with the input var. And then if you wanted to, we can also include that in Slide IDE. So we can have this really nice drop statement as well. And we can have the drop plugin listed. So you don't have to be very masterful at JavaScript to have some amazing interactive experiences with your explorable explanations. The more JavaScript that you know, the more complex you can make something. But again, you've seen here, you can really quickly create these beautiful interactive code cells that can be written in a markdown-like form. And through this, you have this beautifully complex document that gets made that has just so many options. Now, I know I've said a lot of very positive things. I do have to gently emphasize that there are some constraints. So because we're making a compilation into WebAssembly, not all Python and R packages work nicely. You can run into memory limits that, again, if you have a very large data set, will affect the student's ability to really explore the content. Load times in terms of just initializing the document can be significant, depending again on what kind of activity that you're doing. So if you don't have a strong Wi-Fi connection in your classroom, you might not want to have a lot of data sets. You might want to look more towards just generated data. And you have to think about data in a slightly different way, because everything that you're seeing here is really being done inside of a web browser. So you can't immediately go off onto a student's local file system and retrieve a file. Everything file-wise is actually going to be done in this virtual system that will just reside in your browser. When you're starting to initially make these cells for the first time, debugging is also going to be a little bit more challenging, because what happens is, to run pyodide code, we have to actually render the document. Whereas if you're familiar a bit with Quarto before, you used to be able to just run a Python cell and then immediately see the output underneath. So one step that you can take here is to first write your code in Python and then change the cell type into pyoid. And then lastly, George gently mentioned this at the end, but some of the widget support that's native to Jupyter Notebooks hasn't quite made its way into Quarto Live, but it's definitely on the roadmap. So if you already have an existing Jupyter Notebook or something that you're trying to immediately convert with some of the widgets, it might not fully work right at this moment, but a little bit later down the line it should. So some quick resources to also give you a little bit of an idea. Again, if you haven't ever read Victor's Explorable Explanations, it's a really beautiful description of what we can now do thanks to WebAssembly Quarto and Quarto Live. If you're interested in observable as just trying to understand a little bit more, there's a lot of great documentation. Ditto with if you want to come up with very creative pyodide uses. And then last but not least, we have Quarto Live documentation, which is very outstanding. And it will help very quickly in getting you up and getting you going on many of these project creations. So thank you guys so much. I appreciated the invite to come. If you have questions, feel free to let me know. And if you want to keep in touch, I am around on social media and in a few different places.